यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, हम बात कर रहे थे डायनेमिक्स ऑफ सर्कुलर मोशन की और मैंने बात कर ली थी सेंट्रीपिटल फोर्स के बारे में। नाउ आई एम डिस्कसिंग अबाउट द सेंट्रीफ्यूगल फोर्स। सेंट्रीफ्यूगल फोर्स, देखो सेंट्रीफ्यूगल फोर्स को हम कैसे डिफाइन करेंगे। अभी जब हमने सेंट्रीपिटल फोर्स की बात करी तो मैंने आपको बताया था कि जब भी कोई बॉडी सर्कुलर मोशन में घूमती है तो देयर मस्ट बी वन कंपोनेंट ऑफ द रियल फोर्स व्हिच विल बी एक्ट टुवर्ड्स द सेंटर ऑफ अ सर्कल एंड दैट इज कॉल्ड सेंट्रीपिटल फोर्स। नाउ व्हाट इज द सेंट्रीफ्यूगल फोर्स? सेंट्रीफ्यूगल को मैं कैसे डिफाइन करूं? देखो, इफ वी ऑब्जर्व अ बॉडी from rotating frame, then we have to apply a pseudo force on the particle in rotation. Like, if you will observe it, now it is moving, with omega, right? Now if we look at this particle which is present on it, m, मान लो इसकी रेडियस r है, it is also rotating with it. Now it is rotating with a constant angular velocity, let's suppose. So if we observe this particle from frame of this rotating frame, अगर मैं इसको रोटेटिंग फ्रेम से ऑब्जर्व करूं, ओमेगा से घूम रहे हैं, एंड इफ आई ऑब्जर्व इट फ्रॉम रोटेटिंग फ्रेम, इसको मैं रोटेटिंग फ्रेम से ऑब्जर्व करूं तो आई हैव टू एक्सर्ट अ फोर्स ऑन इट corresponding to the rotation, because rotation is also a non-inertial frame. Rotation is also a non-inertial frame. क्यों? A particle या a frame in rotation in circular motion a frame in circular motion has centripetal acceleration. And now when we observe particle from circular frame, then we have to apply pseudo force. Opposite in a direction to centripetal. having magnitude m into AC, mass into centripetal acceleration, and this force is called centrifugal force. This force is called centrifugal force. मतलब if it is rotating and we will exert a force on it, so the force is exerted in opposite to the center, pseudo force. It will be how much? M into AC, centripetal acceleration. What is AC? Omega square into R. So it is the centri pseudo force which is m omega square R, right? So here pseudo force Fp and you can say it is a centrifugal. Is it clear to all of you? So this is the definition for the centrifugal force. Yeah, you can also write it as mv square by r. V square by r, right? Next. Now we are observing some specific circular motion and their dynamics. As I am taking a case that is a horizontal circle. When anything moves in horizontal circle. So let's suppose this is a code, a mass is attached to it and it is rotating in horizontal circle. It is a length of chord L. Now, if it is rotating in horizontal circuit, it has some velocity V. So here tension will act as a centripetal force. So we can write here tension is equal to centripetal force. And it is equal to mv square by L. You can write this thing from the dynamics of the horizontal circle. The next one is the conical pendulum. देखो ये क्या है? This is attached at this point and this is rotating in this circle. It is rotating in this circle having center at this point. If it will have center at this point, Let's go, this angle is theta. Now it is the center at this point. Let's go, the length of the string is L. This is R. The radius of the circle in which it is rotating. So you can say कि what is R by L? It is sin theta. So what is R? It is L sin theta. Right? So R is L sin theta. Now which are the forces acting on it? The mg is acting downward. Tension is acting in this direction. Now tension will have two components. If this is theta, this is also theta. T cos theta. This is T sin theta. So we can easily say that T sin theta is acting towards the center. So T sin theta is equal to centripetal force. So it is equal to mv square by r. If it has velocity v, तो you can easily say कि it is mv square by r. Velocity v के पीछे की तरफ होगी. प्लेन में होगी वो उसके. mv square into r. What is r? L sin theta. And t cos theta is mv square by r. R लिख रहा हूं मैं इसको. It is m into g. Take the ratio both. Tan theta is v square by rg. So what is v? Root rg tan theta. And what is r? L sin theta. R is L sin theta. Is it clear? So this is the case of the conical pendulum. So in the conical pendulum, you can straightforward say कि in the case of conical pendulum, the component of the tension will act towards the center and it will provide the centripetal force. Clear? Next. Next is case bending of cyclist. To take safe turn. Generally it is find out कि whenever we are driving very fast, तो हमने देखा है जैसे बाइक रेसिंग होती है तो उसके अंदर लोग जब टर्न लेते हैं तो टर्न लेते हुए अपने आप को थोड़ा सा बेंड कर लेते हैं. क्यों बेंड करते हैं? वी वांट टू सी दिस थिंग. मान लो इट इज अ पाथ एंड द टर्न, दिस इज द टायर ऑफ द साइकिल दैट विल गेट टर्न बाय सम एंगल. इट इज रोटेटिंग इन दिस डायरेक्शन. वो ऐसे घूम रहा है और उसने अपने को हल्का हल्का टर्न कर लिया. मतलब रेडियस इज एडजस्टमेंट, सेंटर एट दिस पॉइंट. इज इट क्लियर? मान लो सेंटर इज एट दिस पॉइंट. This is the point of center. Right? Now, when it get turned by some angle, let's suppose it turned by an angle. Turn by an angle, let's suppose phi. And theta. Now, which are the forces acting on it? There is a normal action acting towards it. Fn. In this direction. And there is a mg is acting. Now, there is a component of Fn. This component is Fn cos theta. Fn sin theta. It means you can easily observe if it wants to take safe turn, then Fn sin theta is this component which is acting towards the center. So you can say Fn sin theta, it is equal to m into v square by r. It is equal to centripetal force m into v square by r. And what is Fn cos theta? Is equal to mg. Fn cos theta is equal to mg. So we can easily observe this thing. कि tan theta is equal to v square by rg. So what is a v? Root rg tan theta. Here v is equal to safe speed to take turn. At a given bending angle. Alright? So this is the case for it. Is it clear? Next is circular turnings of rod. So we are discussing the first case by friction only. Here, if at the time of turning friction is present on rod to provide safe turn. Like this is the road and the body is taking a turn. Now when the body is taking a turn, it has velocity in this direction, but its center is toward this. And when it is increasing its velocity, then it has a tendency to slip outwards. So tendency to slip outwards. Tendency to slip outwards. For increasing speed. अगर इसकी स्लिप करने की टेंडेंसी बाहर की तरफ है, तो if it will not slip, then the friction on its tires will acting in this direction. ये सिर्फ टेंडेंसी है, that is the static friction. And second thing, the mg this time is acting downward and normal reaction is acting upward. So I am showing like this. Let's say it is invert the plane. Fn is acting there. So we can easily observe that it is acting as centripetal force. So we can say this thing, Fs is equal to mv square by r and Fn is equal to mg. Now what is Fs? अगर वो स्लिप नहीं कर रहा तो it is us max into mg. What is us max into Fn? Fn is mg. M and M will cancel out. So what is V? Root us max into Rg. Safe speed to take turn. With friction to take turn. This is this. Is it clear? Now the next, by banking. बैंकिंग होता क्या है? देखो, बैंकिंग is to make road inclined at the time of circular turning. Due to banking, component of normal action provides centimeters. This is the thing here. रोड को थोड़ा सा इंक्लाइन कर दिया. Let's know this is the road. It is a banking angle. Angle of banking. And the car is moving like this. This is the road. It is a circular turning at this point. And the particle here, the car that is taking turn, it is at this location. Let's suppose it is at this location. It is taking turn at this location. If it is taking turn, I think ये आपको समझ आ गया होगा. जैसे ये हमारे पास रोड है और कार हमारी ऐसे आके ऐसे जा रही है, ऐसे. बैंकिंग एंगल यहाँ पर है तो इसका सेंटर इधर, तो इसकी वेलोसिटी तो कहीं इधर होगी. But if you observe it, there is a normal action on it. This is Fn. There is mg acting downward. Now, you can easily observe that center is in this direction. So we can easily resolve the components of it. Fn के component आ रहा है हमारे पास. This angle is theta. This angle is theta. इसके perpendicular ये है, इसके perpendicular ये है, तो this angle is also theta. If this is theta, we can easily say this is Fn cos theta, Fn sin theta, and this is Fn cos theta. So here Fn cos theta is equal to m into g, and Fn sin theta that is mv square by r. We will take the ratio. Taking ratio, we get tan theta is equal to v square by rg. So v is equal to root rg tan theta. This is a safe speed. So this is the safe speed for given banking angle. At a given height. Right? Case 3 is with banking and friction both. इसमें ये पार्ट देखो 3 का ए, if speed is less than root rg tan theta, अब इस केस में देखो क्या होगा, अगर स्पीड रूट आर जी टेन थीटा से कम है, इफ इट इज लेस देन रूट आर जी टेन थीटा, मतलब ये हमारे पास है बैंकिंग, this is the angle of banking theta, this is the rod, right, and this is the body and mass. Speed is less than root rg tan theta, अगर उससे छोटी है, देखो अब ये घूम रहा होगा, if its speed is less then it has a tendency to move in downward direction, so the friction on it will act in upward direction. The main important thing. Similarly, normal reaction is also acting in this direction, and mg is acting in downward direction, right? But what is the direction of center? This is the direction of center. So there is a component of Fn in this direction. The component, this angle is theta, Fn का एक component इधर आएगा, एक component ऊपर जाएगा. Similarly, friction का एक component इधर आएगा, एक component इधर जाएगा. Now, let us observe it. This angle is theta, this angle is also theta. So this is f cos theta, and here it is f sin theta. Plus एक नॉर्मल का भी आएगा, नॉर्मल का ये एंगल थीटा होगा, एफ एन कोस थीटा, एंड दिस इज एफ एन साइन थीटा, राइट? सो दीज आर द फोर्सेस दैट आर एक्टिंग ऑन इट. सो व्हेन स्पीड ऑफ बॉडी is less than root rg tan theta, then it has tendency to slip downward. And friction will act upward long line. Here friction and normal action both provides centrifugal force. तो यहां पे देखो क्या होगा, Fn sin theta minus f cos theta mv square. एंड एफ को क्या लिख सकते हैं, म्यू एस मैक्स इंटू एफ एन एंड एम जी इज इक्वल टू प्लस एफ साइन थीटा एम जी। If we just take the ratio of these two, Fn will cancel out. By taking ratio, we will get Fn will cancel out. Sin theta minus mu s max into cos theta plus mu s max into sin theta mu square by 8। ऊपर से साइन थीटा कॉमन ले लो, नीचे से 10 cos थीटा, ऊपर से साइन थीटा कॉमन लेके नीचे 10 थीटा cos थीटा 10 थीटा बनेगा और ब्रैकेट में क्या बचेगा, अगर ऊपर से साइन थीटा कॉमन ले लिया तो इट विल बिकम 1 माइनस म्यू एस मैक्स cos थीटा डिवाइड बाय, नीचे से cos थीटा कॉमन ले लिया तो इट इज 1 प्लस म्यू एस मैक्स tan theta, right? So what is V? V will come out to be, रूट लगा दूंगा इसके, it is a safe speed and it is a safe speed if the friction is acting in downward direction. Is it clear? If the friction is acting in downward direction, then it is a safe speed. That is under root of root rg tan theta into 1 minus mu s max into cot theta divided by 1 plus mu s max into tan theta। आप इसको ऐसे भी देख सकते हो कि रूट आर जी tan theta को आप क्या लिख सकते हो, जो हमारे पास पिछला v था, इट इज v स्क्वायर। इज इट क्लियर टू ऑल ऑफ यू? लिखो इसे।